All right, guys, there's the second part of this factory review video. I'm going to show you slip and slide, which some of you have never learned. I actually figured this out last year watching a video. So this is just like the previous one we did with the AC method. So here's what we do on slip and slide. We still go GCF first. So what goes into those three? That would be 2. That would leave me with 6y squared plus 1y minus 1. I still do the AC multiplication. So A times C. I still want two numbers that multiply to -6 and that add to +1. And again, that is AC there and that is B there. And those two numbers are still 3 and -2. Now this is kind of weird, but here's what we do for the AC method. I go ahead and jump down to y plus 3, y minus 2. That is incorrect because if I multiplied those, I would not end up with 6y squared. So since I multiplied by 6 to get my number a while ago, I'm going to take this 6 and I'm going to slide it down here and put it underneath these numbers. Now again, unfortunately, I've ran out of room, so I'm going to have to restart over here. But the idea is this. I now have 3 over 6 is 1/2 and 2 over 6 is 1/3. Now I slide that denominator up here, and that's why it's called slip and slide. So it's 2y plus 1 and 3y minus 1. Still can't forget about that 2 from a while ago. So he's got to come up here and be in the front. So that's slip and slide method. Okay, still doing the factoring. 3 terms, take out the GCF. Looks like 2 and x go into all 3 of those terms. So I'd end up with x squared minus 6x plus 9. Now I'm looking at this inside guy. Notice that a is 1 here. So it's that shortcut problem where we multiply to 6 and we add, or excuse me, multiply to 9 and we add the -6, which would be -3 and -3. And because a is 1, we can jump straight to x minus 3, x minus 3. Drop our little 2x down front. Don't forget about him. He was our GCF in the beginning. And there we go. All right, so now going through all of them. This one has 2 terms. The first thing we always do is GCF. 2x goes into both of those. And then I need to look at this guy. He's got 2 terms. Is it a difference of cubes? No. Sum of cubes? No. Difference of squares? No. So this problem was just a very simple GCF problem. And we are done. This guy has 3 terms, but again, GCF, since the first term is negative, we're going to take out a negative GCF. That would leave me with y. Oh, sorry. Good night. Come on. I don't take a y out. Just take out a -5. That would leave me with y squared minus 1y. And then 360 divided by 5 is going to be 72, I believe. Yep, 72. So that would be minus 72. We now look at this inside guy. He is a shortcut 3-term factoring. What multiplies to -72 and adds to -1? That would be -9 and +8. So we would get y minus 9, y plus 8. Don't forget about our GCF from a while ago. All right, this guy has 2 terms. He is not cubes. They are squares, but it's not minus. Therefore, it's not a difference of squares. Therefore, the polynomial is prime. If you can factor out a GCF, though, it is not prime. But nothing goes into x squared and 121. Okay, on this guy, nothing goes into those 3 terms GCF-wise. So we're looking for 2 numbers that multiply to 81 and that add to -9. 81 would be 1 and 81. That adds to 82. 3 and 27. That adds to 30. 4 doesn't divide it, 5 doesn't divide it, 6 doesn't divide it. We end up with 9 being the next guy, and it's 9 and 9. Since there are no numbers that meet these requirements, it's going to be prime. But again, if we would have taken a GCF out there, that wouldn't have worked. All right, so I'm going to go slip and slide here just to remind you of that. Nothing goes into these three terms. There are three terms, so we are either AC method or slip and slide method. If we're going to slip and slide, we still got to go 28 times 5, which is 140, I believe. And then we're looking for two numbers that multiply to 140 and that add to be 39. So over to the side, I'm going to make me a little chart because I probably don't know the factors of 140. 1 and 140 adds to 141. 2 and 70 adds to 72. 3 does not divide 140. 4 is 35. And there are my two numbers, 4 and 35. Now slip and slide, I would do y plus 4, y plus 35, but that is not the correct factors here. I've got to remember that I multiplied by 28 on the AC. So I've got to divide by 28 on those numbers. So I slip that 28 down there, reduce my fraction to 1/7, and 35 divided by 7 is 5/4. Now to get my actual answer, I put the denominators up in front. So it's 7y plus 1, 4y plus 5. You could also AC method that, and that would work as well. All right, looking at these two, first things first is a GCF. 4 goes into both of those, as does a y squared. And I end up with 25y squared minus 4. Inside, that is two terms, so it's either cubes or squares or not factorable. These are squares and they are minus, so it is 5y squared minus 2 squared. My a squared minus b squared says it's a minus b, a plus b. Don't forget about our GCF. And there we go. Again, two terms, GCF comes out. That would be 3x cubed. On the inside, I'm going to be left with 4x squared and 1. Again, that's a difference of squares. So it would be 2x minus 1, 2x plus 1. This is a possible quiz question. Basically, you've got to factor out the fact that x plus 4 is the same in all of them. That would leave you with the quote-unquote loners. And then we'd have to factor that trinomial the way we did there. This is also a possible quiz question. It talks about the model of a building has the shape of a rectangular solid. The height is represented by x, and they give you that and ask you to factor it. So if we factor it, we end up with x times x minus 10 times x minus 10. All right, well, there's the second video for the factoring review. Hopefully that makes sense to you.